In the previous video, we have implemented a cell class responsible for storing information about a single cell of our grid. Now we will implement the grid itself. Let's create a new C# script called MapGrid. Okay, let's open it up in a code editor. Okay, great. Now again, I'm going to place my code in chessmaze namespace, and the MapGrid will not inherit monobehavior. It will be a simple C# class. Now again, we will need some private variables, so private int width and length. Those will define the size of our grid. Next, private cell, a multi-dimensional array of cells. Let's call it cell grid. Great. Again, we can click left on the width and length and create property fields to be able to access those. So let's use property width and let's use property length. But let's delete the setters as we will set those through our constructor. Okay, great. Okay, now let's create a constructor using setor snippet. Tap tab twice to create it, and we will take in integer width and int length, and those will be the parameters for our grid. So this width equals width, all this length equals length. Okay, great. Next, we will want to create our grid. So for this, we will call public void create grid. And here basically we will call cell grid equals new cell and give it length and width. Next, we will create two for loops from I, instead of I, let's call it rows. And we will need to go up to the length, and for column up to the width. And here we are going to simply create a cell. So cell grid row and column equals new cell, and in this constructor we will simply pass column as x and row as z. So now each of our cells will know what is its position. Next, we need to create some helper methods that will make our life a little bit easier. So let's start from implementing public void set cell, int x, int z, and cell object type. And we will call cell grid z and x dot object type equals our object type, and the same cell zx dot is taken equals true. We will use this method to only set our cell to be something different than an empty cell. To make it more generic, we could use a boolean is taken equals false, so predefined value, and set it to is taken, in case you want to use this class to set the cell to be empty. Next, we will do the same. Let's copy this method, but instead of ints we will get float and z as float. Okay, and here we will call our basic set cell method to be int x, int z, our object type, and our is taken. So it should be is taken. Okay, great. Now of course you could just as well pass a vector 3 here, but I did it this way. Next, what we need to do is to have a public bool is cell taken. And again, we will pass int x and int z, and what we will return is return our cell grid z and x and is taken. Great. Now next, public void is cell taken. So actually we can copy the above method, and instead of ints we want to pass float and float. And basically what we need to do here is pass int instead of float. So we need to cast it to int. Great. Next, what we need is to see if the cell is valid. So if we are not asking for a cell outside of the bounds of our grid. So public is cell valid. Sorry, a public bool. So public bool is cell valid. Again, we are going to take float x and float z. We are going to check if x is greater or equal to width, or if x is less than 0, or if z is greater or equal to length, or if z is less than 0. And this will allow us to say that these coordinates are outside of our grid. So let's return false. Otherwise, we will return true. Great. Now a couple more of those. We will need a method that gets our cell, so public cell, get cell. And again, we are going to use int x and int z at the beginning. So if is cell valid, x and z equals false, we are going to return null. And if the cell is valid, we will return our cell grid and pass to it z and x. This will get us our cell that we are asking for. And again, let's copy this method. And we are going to pass, instead of ints, floats. And for z, again, float. And we are going to call our basic return get cell and cast floats as ints. Great. Now we can get cells, set cells, and check if cell exists. What else do we need? We need a way to calculate index from coordinates. So basically, we will store our obstacles as a list of Boolean values in our candidate map class that we will soon implement. And we will need to switch between 1D array, so our bool array of is there an obstacle or not, and our coordinates on the grid. That's why we need a method that will recalculate our position on our one-dimensional array onto our two-dimensional grid and vice versa. So for this, we will need to implement public int calculate index from coordinates. We will here pass int x and int z, and we will return x plus z times width. So basically, this will calculate our index for our position. If you are not yet sure how it works, you can make a little bit of test for yourself by drawing a grid by 3 by 3 and a grid of 9 by 1 and see if this calculation meets your expectation of what you want the index to be. Next, we will copy this method and we are going to paste it below. Instead of ints, we are going to pass floats and float. And again, we can calculate the width by casting those two into as ints. And int. Great. I am pretty sure that casting isn't necessary, but better safe than sorry. And last method that we will create will be a helper method. Let's create a public void check coordinates. And basically what it will do, it will print us all the coordinates of our grid into the console so we can check if our grid was correctly instantiated. So for I equals 0, I less than cell grid dot get length with index 0, we are going to create a string builder. Alt enter if you don't have this system.txt library in usage, and let's call it b equals new string builder. And basically what it will do is concatenate our values for our cells, so the positions of our cells. So for j, because we already have I equals 0, j is less than cell grid dot get length with index 1. Okay, so here we want to call b dot append and open parentheses j plus comma in quotes plus I plus empty space. Great, and after this second for loop we will debug that log b to string. Okay, so this will be our helper method that we'll just use for now to visualize our grid. So let's go back to Unity. Let's create a new C# class called MapGenerator. And let's open it up in a code editor. Okay, so I'm going to add it to my namespace. We are going to create a start method. Okay, and in start we are going to simply call mapGrid. Grid equals new mapGrid. Let's pass it 5 by 5 as parameters, and we will call grid create grid. Actually, we could call create grid as a private method. So let's go to mapGrids, and instead of public, let's make it private. And let's call it inside our constructor. Okay, this will be a little more clean. And now instead of this, we are going to call check coordinates. Okay. So this should print us all the coordinates from our grid. So let's go back to Unity. Let's create a new empty object. Let's call it MapGenerator. Okay, let's drag MapGenerator script onto it. And let's run the game. And now we can see in not very readable form the coordinates 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. So this is the bottom row, and it's go up to 4.4. So we know our grid works correctly and it creates our grid correctly. So knowing that our data structure works correctly, we are going to visualize in a simple form our grid. And this is what we are going to tackle in the next video.